Okay, in Objective 2, we are looking at factoring and graphing polynomial functions. So the first thing you'll see on your notes is a factoring review. My recommendation would be to try those factors on your own. That way you can check your answers here based off what I have displayed. It's nothing new to this class. This is something you would have learned last year. But it's just making sure that we remember kind of the steps of factoring, giving you a little bit of kind of warm-up practice before we get into what is new, which is the graphing side of things. So again, if you have not already practiced graphing, I would pause the video at this point. I would work through those problems that are on your notes on your own, and then check them here as you finish to see, like, do you actually remember what it means to factor? And then if this is something that you need another video of because you don't remember how to factor a difference of two squares or whatever the case may be, just let me know. I will happily make that for you if that would be helpful. Okay, but this particular video is going to be focusing in on the graphing side after you've already factored. What does it look like to graph? Okay, so coming down here, we have three vocab words / kind of thought processes that we need to have under our belt in order to be able to graph accurately. Okay, so first up we have X-Intercepts. So X-Intercepts you would have first seen a number of years ago. They are, if you remember, where we touch the x-axis. And so what it means to touch the x-axis is for y to equal 0. And then we have two other words that we also use to reference where y equals 0. They are roots and then zeros. Which also are found by finding where y equals 0. There's a slight difference between the two, which we are going to discuss, but for all intents and purposes, these three words, x-intercepts, roots, and zeros, are almost synonymous. Almost. Not quite, but almost. Okay? So, to find our x-intercepts, we would let y equal 0, and we'd solve for x. And then if you find a 0, say 2 or 5 or whatever the case may be, that x minus c, that x minus 2 or x minus 5 is a factor of f of x. Okay, and that would mean that c was your x-intercept. Note here, not every polynomial has an x-intercept. It is entirely possible that you would have graphed or would find a function that when graphed never actually crossed through the x-axis. But if it crosses through the x-axis, it would cross wherever y equals 0. Okay? So a kind of quick example of what we're talking about here when we're talking about those zeros. So for example, to make this function equal 0, x would need to equal positive 3. Right? If x minus 3 equals 0, and I could even kind of show that for x minus 3 to equal 0, adding that x or that 3 over x would have to equal 3. And so that's what it means when it says x minus c is a factor. C, that number behind the minus, would have to be your x-intercept. Okay? Y-intercepts. Y-intercepts, we would let x equal 0. Where do we touch the y-axis? And then you'd solve for y. 0, f of 0 then is your y-intercept. So, again, giving that kind of a quick example here, say this was my y equals. If we made our x equal 0, we would have negative 3 times x equaling 0 would be 3, x equals 0, 1. And so my y-intercept would be at 0, negative 9 if this was my function. Okay? And then last but not least, we have multiplicity. Multiplicity of an x-intercept is the number of times the 0 occurs. Okay? And so that, in essence, what that's asking us is what is the exponent that's attached to that particular factor. Okay, so for this particular one, we'd have an x-intercept at negative 3. Well, it has a multiplicity of 1. So it only occurs one time. We have an x-intercept at positive 3. It has a multiplicity of 1. And then back here out front, we have an x-intercept at 0, but that 0 occurs twice. Right? So 0 has a multiplicity of 2. Okay? And so that's all multiplicity is. So example 2 here, we're finding x and y-intercepts and stating the multiplicity. We'll walk through the first one together. And then my recommendation is to pause the video, walk through that second one on your own, restart it either when you are stuck and need an explanation, or when you think you have an answer and are ready to kind of double check that answer and potentially hear an explanation if you got part of it wrong. Okay? But let's go ahead and do A together. So x-intercepts, y-intercept, and multiplicity. I'm sorry, we're going to state the multiplicity within our x-intercept. So x-intercept, y-intercept, and then we will be stating multiplicity. So x-intercepts here, as I'm looking at my factors, the first one here, what would make x squared equal 0? It would be 0. And there are 2 of those, so that 0 has a multiplicity of 2. Okay, next up we have x minus 4. What would make x minus 4 equal 0? It would be positive 4, because then 4 minus 4 would be 0. And this one has a multiplicity of 1, so we don't actually write multiplicity of 1. It's an understood multiplicity. So we're going to just write 4. And then at the back, what would make this equal 0? That would be negative 5. And that also has a multiplicity of 1, so we aren't going to write anything. Okay? Y-intercept. Y-intercept is when x equals 0. So if I plug in 0 here, we get 0 times plugging in 0 here, negative 4 times plugging in 0 here, 5. 0 times negative 4 times 5 is 0. And so when x is 0, my y is 0. Okay? And so that's my y-intercept. Okay? B, go ahead and pause the video, give B a shot, restart it when you are ready. Okay, here we go. X-intercepts. So what makes 2 equal 0? Nothing. 2 is 2. Next up, what makes x minus 1 equal 0? That would be positive 1. And there are 2 of those x minus 1s, so this has a multiplicity of 2. And then for our last factor, what makes 3 minus x equal 0? That would be positive 3. And it has a multiplicity of 1. Okay. Y-intercepts. What happens when x equals 0? Well, if I plug that in, we have 2 times plugging in 0 would be negative 1. Squared is positive 1. Times plugging in 0 here. 3 minus 0 is 3. 2 times 1 times 3 is 6. Okay. Okay, so let's get into the graphing piece here. So multiplicity. If the multiplicity of the x-intercept is odd, right, 1, 3, 5, 7, 9, etc., then the graph of the polynomial passes through the x-axis. And so what that would look like is, for example, something like this. This has an odd multiplicity. Or like this one. This has an odd multiplicity because we see it passing through the x-axis. Okay? If the multiplicity of the x-intercept is even, 2, 4, 6, 8, etc., then the graph of the polynomial bounces. It touches the x-axis at that x-intercept but does not cross through. And so that would look like this one, which has an even multiplicity, or this one, where we see it touch the x-axis but not pass through. It bounces off it. Okay? And so that fact, or those 2 facts, are what are going to guide our sketches here. We're going to factor and then sketch the graphs of the polynomial functions. It is a kind of an emphasis here. It is a sketch, not exactly the right graph. We are not looking at exactly where our maximum or our minimum are, but roughly speaking what our function should look like. Okay? So here are some steps. Step 1, if necessary, we are going to factor. Okay, well, looking at my first example here, it's already in factored form, so step 1 is done. Step 2, we're going to find the x-intercepts in multiplicity. Well, this is what we did in those first two examples that we just looked at. So x-intercepts in multiplicity. What makes 2 equal 0? Nothing. What makes x plus 3 equal 0? That would be negative 3, and it has a multiplicity of 2. And at the back, what makes x minus 4 equal 0? That would be positive 4. Okay, step 3, we are going to find the y-intercepts. Again, this is what we just did on the front. So my y-intercept, what happens when x equals 0? Well, when I plug that in, we get 2 times 0 plus 3 is 3, squared is 9, times 0 minus 4 is negative 4. 2 times 9 is 18, times negative 4 is negative 72. Okay, step 4, we're going to find the degree and the sign of our leading coefficient. So this is back in objective 1. We were looking at identifying degrees and leading coefficient. Okay, so degree, what is my highest exponent? Well, we have 0 out front. We have 1 in this first term as my highest degree, and there are 2 of those 1s. So we have 0, 1, and another 1. And back here, my highest exponent is again 1. So 0, 1, and another 1, and 1. 0, 1, and another 1, and 1 makes the highest exponent of 3, or a degree of 3. My leading coefficients, we have a 2. In this first one, our leading coefficient is 1. And there's another one of those 1s, because this is squared. And in the back, my leading coefficient is 1. For a total leading coefficient of 2. And then we're going to make a basic sketch based on the end behavior. So here I have a degree of 3, so an odd degree, and a positive leading coefficient, which tells me that since I have an odd degree and a positive leading coefficient, I should see my function going down to negative infinity on the left and up to positive infinity on the right. As I graph, I'm going to be plotting the intercepts. So I have an x-intercept at negative 3. Slide this up here. So I have an x-intercept at negative 3 and an x-intercept at 4. You want to make sure that you take note of where your bounces are. So again, a bounce up here is when we have an even degree. Or sorry, bounce is when you have an even multiplicity. And so for my x-intercepts down here, I have an even multiplicity, a multiplicity of 2 at negative 3. So this here is going to be a bounce. 4 is going to be a cross through, a pass through. Okay. And then you're going to sketch a continuous function so that that end behavior is seen. Again, we said odd degree, positive leading coefficient. We should be at negative infinity on the left, positive infinity on the right. Okay, so starting here, I'm coming up. I'm going to bounce at negative 3. Something like that. My y-intercept was at negative 72, so I'm going to call, that's going to be negative 72 there. Okay, so it's going to come down. It's going to pass through negative 72. And then it's going to come up and cross through that one there. And again, this is a sketch. I don't actually know where this relative minimum is, so on my sketch it's kind of at like roughly x equals 1 or so, but I'm not really concerned with finding exactly where that relative minimum is yet. You are building to that throughout this class heading into calculus, but for now we're just going to kind of roughly sketch these attributes. Okay? So let's go ahead and do one more together here, but then my recommendation for the last 3 is that you pause the video, give them a shot on your own, and then restart it either as you are stuck or as you think you have answers but are ready to double check that you did in fact do them correctly. Okay? Let's do one more together here. So, step 1, we want to factor. Done. Okay? Step 2, we are identifying our x-intercepts and their multiplicity. So my x-intercepts here are at 4, positive 4. with a multiplicity of 2, and at -1 with a multiplicity of 2. Next up, my y-intercept when x equals 0. Plugging in 0, we would have our -1 times -4 squared, or 16, times 1 squared, which is 1, so my y-intercept is at 0, -16. Then we have our degree and our leading coefficient, which are going to tell me what's happening with my end behavior for my sketch. Okay, so degree here, we have a degree of 0 out front, a degree of 1, and there are 2 of those 1s because of this squared, so 1 and 1. At the back we have a degree of 1, and again there are 2 of those 1s. So 0, 1, 1, 1, and 1 makes a degree of 4, or an even degree. So I know I'm going the same direction for my end behavior. My leading coefficients are -1. Leading coefficient in here is 1, and there are 2 of those. And back here we have 1, and there are 2 of those. So my leading coefficient is -1 times 1 times 1 times 1 times 1, which is -1. So with an even degree and a negative coefficient, I know I'm going down to negative infinity on both sides. Okay, so graphing this, we have an x-intercept at 4, and it has a multiplicity of 2, so it's going to be a bounce. An x-intercept at -1, it has a multiplicity of 2, so it's going to be a bounce. And a y-intercept at -16, which I'm going to put right here. There's my y-intercept of -16. And then even degree, negative leading coefficient, so we're negative infinity on both sides. So I'm going to go ahead and come up here. I'm going to bounce. So I'm going to sketch this a little bit further out just to give it kind of that continuous curvature here. So I'm going to come up this way and bounce. And go ahead and come down. And back up again and bounce. And back down to negative infinity. So something roughly speaking like this. Again, this is by no means an exact sketch, but it's a rough one of kind of what this function would look like. Okay, so again, my recommendation on each of the next 3 is to pause the video, give C a shot, restart it when you are ready, then pause the video again after C, after you've checked your answers or heard an explanation for whatever you needed explained. Pause the video again, do D, and then restart the video when you're ready. And then pause the video again, do E, and restart the video when you're ready. That way you're figuring out what is it that you are actually understanding and what is it that you need to come in and kind of ask for a little bit more help on. Right? So go ahead and pause the video, give C a shot. Okay, this one does need to be factored. So if I pulled out an x, we would have x squared minus 4. And then this is a difference of 2 squared, so x minus 2, x plus 2. X-intercepts, we have 0, multiplicity of 1, positive 2, and negative 2, all multiplicities of 1. Y-intercept, what happens when x equals 0? When x equals 0, we have 0 times negative 2 times 2. 0 times negative 2 times 2, which is 0. Degree, we have degree of 3, and actually I can see that from my original function here, 3. Or you can find it by doing 1, 1, and 1, which is also 3. And a leading coefficient of positive 1, which again we can see from here, the positive 1, or from doing 1 times 1 times 1, which is 1. And so with an odd degree and a positive leading coefficient, I know I'm going to see negative infinity on the left, positive infinity on the right. We've got intercepts at 0, negative 2, and 2, which are all going to be crosses because they all have odd multiplicity. We've got a y-intercept at 0, 0. I've already plotted that. And again, negative infinity on the left, positive infinity on the right. So we're looking at kind of something roughly speaking like this for our sketch. Okay. Go ahead and pause the video, give D a shot. Restart it when you're ready. Okay, factoring. G of x is a trinomial that factors. We have x squared minus 16 and x squared minus 1. And then both of those are differences of two squareds. So we have x minus 4, x plus 4 from the x squared minus 16. And x minus 1, x plus 1 from the x squared minus 1. Okay, so x-intercepts. We have x-intercepts at positive 4, negative 4, positive 1, and negative 1. All have multiplicity of 1. Y-intercept, when x equals 0, we would have negative 4 times positive 4 times negative 1 times positive 1. Y would therefore be 16. My degree, I can see that either from the factored form or from the initial. My degree would be 4. And my leading coefficient, again, can see it from the factored form or from the initial. My leading coefficient would be positive 1. And so with an even degree and a positive leading coefficient, we would have an in behavior of going to positive infinity on both sides. And so as I graph this now, x-intercepts at 4, negative 4, 1, and negative 1, all of which are crosses because of their odd multiplicity, and an x-intercept of a y-intercept of 16. As I plot those, I need to make sure that I have positive infinity in behavior on both the left and the right. So it's going to look something, kind of roughly speaking, like this. Okay. Again, it's just a rough sketch. And then we have some questions here. How many x-intercepts do we have? Well, we have 1, 2, 3, 4. How many relative maximums? Only 1. How many relative minimums? 2. Okay, go ahead and pause the video, give E a shot, restart it when you are ready. Okay, so with E here, our function is f times g. So my function is going to be x times this negative x cubed, negative 6x squared minus 9x, which if I multiply that x then means we are negative x to the 4th minus 6x cubed minus 9x squared. Factored, I can pull out a negative x squared as a GCF, so we'd have x squared plus 6x plus 9. Which does trinomial factor to x plus 3 times x plus 3, which is the same thing as x plus 3 quantity squared. Okay, so x-intercepts, we have 0, which has a multiplicity of 2, and negative 3, which also has a multiplicity of 2. Since they both have even multiplicities, they're both going to be bounces. Okay, y-intercept, when x equals 0, we would have 0 times 3 squared, or 9, times a negative, which is 0. My degree, looking at my original function up here, my degree is 4. And my leading coefficient is negative 1. So with an even degree and a negative leading coefficient, I know my graph is going down to negative infinity on both the left and the right. So I need to make sure that's in my sketch. Okay, so x-intercept at 0, multiplicity of 2, so it's a bounce. And at negative 3, again, multiplicity of 2, so it's also a bounce. Y-intercept at 0, that's already plotted. And then even degree, negative leading coefficient, we'll see negative infinity on both sides. So we're bouncing here, and down, bouncing again, and down to negative infinity. Okay, so how many x-intercepts do we have? We have only 2 x-intercepts. Now this is where we make a slight distinction between x-intercepts and those other 2 words we threw in at the beginning of this set of notes, at the beginning of this video, which was roots or zeros. Because if you notice up here, we actually have 4 zeros. We have 2 at x equals 0, and we have 2 at x equals negative 3. So 4 zeros. 4 potential x-intercepts, but only 2 actual distinct x-intercepts here. Only 2 places where I actually touch the x-axis. 4 zeros though. Okay. How many relative maximums do we have? We have 2. How many relative minimums? 1. Okay. And so that's graphing polynomials.